All right, exercise 5D. This is from your textbook. Question 4. For those who went up to this last week or so, let's do it together. When they say implied domain, hands up if you know what implied domain means. What's implied domain? Anyone know? Someone said something? You are implying X. It's literally true. Yes, exactly that. And so, unlike all the other questions you get, normally we define the domain for you. So for example, if I gave you y equals x squared, and then I say where x is an element of r plus, out of curiosity, anyone remember what r plus means? Good. This is not including 0. So remember 0 to positive infinity, that's what that means. Okay? So if you say that, at least you now know the domain is r plus. But that's explicit. Implied means that I don't tell you, and you're meant to figure it out. There are some restrictions. Now, all of these functions here have a restriction, most of which are pretty obvious. First one, what's the restriction when you have a square root function? What can't you have? You can't have a negative. So the question is, when will x minus 4, because that's the inside, you're square rooting whatever x minus 4 is, when will x minus 4 be negative? So the only way to sort of figure it out is, well, when is it less than 0? So let's solve for it. X plus 4 on both sides. That means, when will it be less than 0? When x, if the number of x is smaller than 4. So if x is smaller than 4, this function will not work. So what's the domain? When will it work then?
When x is bigger than 4?
Yeah. So when x is bigger than 4, but there's also another caveat. Can it equal to 4? Why? Yeah, because you can have 4. 4 take away 4 is 0. Root of 0 is 0. So that's your domain. But we call that implied domain because we didn't tell you, and you had to know that by looking at the equation. Does that make sense? Otherwise, another way to sort of visualize it, another way to know it is to visualize it. If you visualize y equals root of x minus 4, go back to chapter 4 now. Hopefully you know how to read left and right. This is a square root function, so we know that usually it looks like this. What's the x minus 4 tell me? What's that x minus 4 tell me? Left or right. So in this case, what does it tell me? Moves to the right. Remember, I said whatever you're square rooting, whatever you're affecting the x, that tells you left or right. So if I let it equal to 0, that's the technique I taught you guys. Solve for x equals positive 4. So that implies it moves to the right by 4. So this graph here, instead of starting at 0, starts at 4 and looks like that. Exactly what Sion said before. Has to be greater than 4. And then we said it has to be equal to 4. So right at 4 onwards, it will work. Anything less than 4 won't work. That's what we tested algebraically. This is graphical. So the better for chapter 4, if you can picture them, you can figure out the domain. This picture, this one, B. See if you can picture B. Y equals to the root of 4 minus x. Be careful of that minus. What does this graph look like? It's a square root. It's good. So it has that shape. But let's work out. Does it move left or right? Right. This moves to the right by 4 if you solved it. So 4 minus x equals 0. Add x on both sides. X equals 4. So it moves to the right by 4. So right by 4. Great. But why did I say be careful of the negative? Yeah, when you have a negative on the x, now which one is it? Is it like this, like this, like this, or like this? So 1, 2, 3, or 4. Which one is it? 2. 4 is the one when you have a negative at the front of the set. If you have a negative on the x, all the x values from positive becomes negative. That's why it's a flip horizontally. So number 2 is what it should look like. Okay, so that's graphical. So if you can read the transformations from chapter 4, it's easier to read now. What's the domain? What will work? What's the domain of this graph? Can anyone see? What x values can this graph take? Ben? Yeah, all of this. Because the graph clearly was only from here onwards. You can't take anything bigger than 4. It can obviously be the point. And remember how I taught you in class? I said that I taught to that student who just totally didn't get domains and range. And I said, just keep drawing vertical lines until you can't get one on the graph. You can see it gets up to 4. So negative infinity up to 4 is the answer for B. So B, if they ask you what is the implied domain or what is the domain is x has to be less than or equal to 4. Okay, or you could say what Ben said before, negative infinity up until 4. So x is an element of that. Either way, it's both correct. So set notation, interval notation, or standard notation. Let's try the next one. So the better you can graph these, which is chapter 4 stuff. If you can't graph it yet, use a calculator. But eventually, you want to be able to do what I just did. You should be able to read the graphs. So if that's a skill that you haven't practiced, then over holidays, chapter 4, you want to be able to read each transformation. Let's try the last one. F. What type of graph is F? What type of graph is F? Yeah, it's hyperbola. Doesn't have a square on the bottom, so it's not truncus. So hyperbole should look something like this. Well, let's read the transformations. What's a minus 4 tell us? Down by 3. So now I know the graph shifts down by 3. Then, same thing as what I taught you. What's x plus 2? Left by 2. So instead of the vertical asymptote being here, left by 2. So here we go. There is no negative on the function, so it must still look something like that. So if I take off the red ones, well, sorry, it should be like this. There you go. Now you got the graph. If I asked you, what's the domain? So if you had to draw vertical lines, where would it not have a value?
Well, I wrote it down, but you do x is an element of all real numbers excluding 3.
Beautiful. Oh, not 3.
No, I mean, not 3. 2.
Negative 2.
Negative 2.
Very good. You can see on the graph, you can take every value here. You can take every value this direction as well. The only value you can't take is literally on the asymptote. So that means x is an element of all numbers. And remember, when you're doing except or exclude, which one is it again? Backslash or forward slash? Backslash. Okay, so backslash, negative 2. That's the domain. So when they say implied domain, it just means they give you a function you're meant to know. You're meant to know what the restrictions are without us telling you. Okay, so that means that you have to know chapter 4 well. All right, team. So if I answered the questions there, your A part was x is greater than or equal to 4. B was again x less than or equal to 4. And I just did F, which is x is an element of all real numbers except negative 2. You guys can do C, D, and E in your own textbook. There's solutions there for you to check. All right, next question. Question 7a, I already sketched the graph for you, okay, rather than going through the algebra. So this is chapter 3. You have to know how to sketch x squared minus 2. For me, I just looked at that and said it goes down by 2. So it went down by 2. Solve for the x-axis intercepts. So all I did was to solve for x-intercept, let y equal to 0. Add 2 on both sides. Square root both sides. That's root 2 and that's negative root 2. That's what I got. Okay, so this is technically negative root 2 and that's root 2 there. Okay, so that's your x-intercept. That's how I worked it out. I said let y equal to 0. Solve for x. Add 2 on both sides. Square root both sides. That's your positive. That's your negative. Cool? So here's your graph. We've done part A. Drawn. Because that wasn't the essence of this exercise. The essence is B. 7b. It asks you to restricting the domain so that you can form a one-to-one function. Let's remind ourselves, how do you test again for a one-to-one function? Which one is it? There's a vertical line test and there's a horizontal line test. Which one is it? It's horizontal. What's the vertical line test? Yeah, so this is asking, is it a function? Clearly, this is a quadratic function. Yes, vertical lines make it work. So it is a function, but we're not interested in that. We're interested in, is it a one-to-one function? Horizontal line test shows this is not a one-to-one function. This is a, what's this called? A many-to-one, because it has many x's. Remember, it has many x's, but only has one y value. So it's a many x to one y function, right? So this is going back to 5C. So revision of 5C if you haven't practiced that yet. That's to tell what type. So they don't want a many-to-one function. They're asking you now, fix the domain, because clearly the domain at the moment says you can be any number. So your domain is R. But I don't want R, because if I have R, it is going to be a many-to-one. How do you restrict the domain? Where do I cut off so that I have a one-to-one? Where would I cut off on the domain? What should the domain be instead? So what should the domain be? Where to where will ensure that when I draw a horizontal line test, it will not cross twice, it only cross once. Beautiful. Can you guys see where the turning point is? Right here, if I went all the way down and I stopped here, so at x equals 0, if I cut it off there, that line will not repeat itself. You can do a horizontal line test and it will always cross once. But as soon as you pass 0, it curves back up. So you get two solutions. So that's why your two possible answers are, you either have negative infinity all the way up to 0, so from here to here, that graph, this part of the graph that I'm coloring in purple here, that's a one-to-one. Right there, that's a one-to-one. That's not a many-to-one. If you do a horizontal line test, just that bit there, that will be a one-to-one function. But you could also have this other side. This side, that is a one-to-one as well. So that's why they asked you for two, they set up here, two one-to-one functions. So what are two possibilities? One, this is what we're going to do. Using function notation, so F, first bit is domain. Now Ben told me the domain was negative infinity up until 0. So I write here, negative infinity up to 0, inclusive of 0. Don't include negative infinity. Maps onto the codomain, which is R, which I haven't described what that is yet, but it's always going to be R for methods, comma, your function. Your function was x squared minus 2. This is one answer. What's the second answer? How are you going to write the second one? I'm filling out most of it for you now. What goes here? What's your second one? Yeah, this is the other one. From 0 to infinity, if you just want this side of the graph, that will be a one-to-one. So it has to be 0 is the smallest value to positive infinity. So here, your answer should then be 0 inclusive, positive infinity, maps onto R, and that's what they're training. Okay, so if you haven't done 5D or got up to this question, that's a really good one to tie in a lot of things, because it ties in, do you know how to sketch quadratics? Do you know how to read the function notation? Do you know how to use VLT and HLT? And do you know how to write function notation with domain? So in one exercise, one question really trains your understanding of chapter 5. Does this make sense? Last one is for you to try. Okay, so last one I didn't sketch the graph. That's a truncus function there. How would you restrict the domain so that, again, same thing, you get two one-to-ones? All right, that's it for today. Have a go with those blank ones, or you can work on wherever you're at, but that's the idea. Okay, so this holidays, what I want you to do is make sure whatever we've taught this term, build the algebra. So chapter 3 is key, chapter 5 is next, but we're going to finish off chapter 5 next term anyway. Okay, but at least learn domain range, function, one-to-one functions, types of relations. That's going to be key. All right, I'll stop the video there. That's 14 minutes of me.